Example 3, we're graphing a plane curve, and so it's important to notice that you're graphing a set of xy points. Okay? X is given by 2 sine t, and y is given by 3 cosine t, and we're graphing it for t in the interval from 0 to 2 pi. So we're just going to think about this as a set of xy points. So let's go to Desmos and type it in. Okay, so we get part of it anyway, but we notice the interval is not set correctly. So let's change that from 0 to 2 pi. And what we see is an oval. We see an oval. I think it's interesting to play around with these numbers and see how they change things. Make them wider and taller and stuff. But here we've got our oval, and it looks like it goes from -2 to +2, from -3 down here to +3 down here. So this example wants me to sketch it. Let's make a quick sketch. 1, 2. 1, 2, 3. Not perfect, but we can definitely tell that that's an oval. That's a really easy thing to do with this graphing software. If I didn't have a graphing software, I'd have to change this to rectangular. If you can remember what a rectangular equation looks like, it's going to end up looking like x over 2 squared plus y over 3 squared equals 1, or x squared over 4 plus y squared over 9 equals 1. You'd end up having to convert to rectangular if you were doing it by hand. We don't have to. Let's look at example 4. Give 2 parametric representations for the equation. Okay. Now remember what parametric representations are. When they say that, they're talking about x equals some function of t and y equals some other function of t. That's what they want. And so give 2 different representations. What they're asking us to do is just basically make something up. And so I'm going to keep it simple. I'm just going to let x equal t. That's about as simple as I can possibly make it. And let's see what happens to y in that case. If x was equal to t, then y would equal, just plug in t right there. Okay? Plug in t right there. You'd have t minus 2 squared plus 1. That's it. That's all they're asking for. Parametric equation, x equal t, y equal t minus 2 squared plus 1. So they want 2 of them. Let's give another one. Let x equal, and I can really pick anything I want. Okay, make it tough, make it easy, whatever. Just have to choose different than t. So let's say we did t plus 5. Okay, x equals t plus 5. So what they're saying is x equals t plus 5 would go right there. So then y is going to equal, you've got t plus 5 minus 2 right there. I'm just going to turn it into t plus 3. Y equals t plus 3 squared plus 1. Okay? That's 2 different parametric equations. Let's just give a third one just because we didn't have to. But imagine if I had let x equal, let's say that was t plus 2. T plus 2 is a good one to use. Let's say we pick t plus 2. Because if I use t plus 2, I would have t plus 2 minus 2 in there. Those 2's are going to cancel out. So if I used x equal t plus 2, then y is going to equal t plus 2 minus 2 is just t. I'd have t squared plus 1. That'd be a different way of representing. That's a good way. So any of those 3 or anything else you can dream up really would be an acceptable answer.